Hi friends, the next question to look at is merging of two sorted linked lists. Here we have two sorted linked lists, which means we have two linked lists. Each one has got the data which are sorted. That means the first node has got a smallest element, and as we proceed further, the size of the element or the value of the data keeps increasing, or other way. That's what we call sorted linked list. So we are having, for an example, two sorted linked list, L1 and L2. L1 is having the values 1, 3, 8 and 16, and L2 is having 2, 5, 6 and 20. So the logic is to sort the two sets. So we have two sets of data with us. So we need to sort them and get a new sorted set. So that is what is the logic used. So we like the data output to be 1, 2, 3, 5, 6, 8, 16 and 20. So how it is done? So we know that the first element in both the list is the smallest in that particular list. So we look at the first element in the first list, first element in the second list, and both happen to be smallest in their own lists. So therefore, one happens to be smallest in the first list, two happens to be smallest in the second list, and then compare these two, and we realize that one is the smallest, so we just copy one first. And once this work is over, then the next smallest in this list is 3. This is still unused. Now compare these two smallest, so 2 and 3, therefore 2 finds smaller, so 2 is copied on, and then we have 5 as the smallest. Then 3 and 5 are compared, and we find that 3 is smallest, so we copy 3 there, and then 3 is no more available in our list. Then the next smallest element in first list is 8. 8 and 5 are compared, so 5 happens to be smaller, so 5 is copied and removed from the second list, and then 6 is the next smallest in the second list. Compared these two, 6 and 8, then we found that 6 is smaller, then 6 is copied, and then the next smallest is 20. 8 and 20 are compared, so we realize that 8 is smallest, therefore 8 is copied, and then the next is 16. Between 16 and 20, 16 is found to be smaller, so 16 is copied, and that's it. And finally we are left with only 20. So that's how it is done. So what we did, we have used one value from each list which is in the beginning of the list. So that's the logic we are going to use. So to solve the problem, let me create a new list. Let me call it 1 L. Okay, then L1 and L2 are the pointers to the first nodes of the two list. So let me try. L1 dot data is smaller than L2 dot data. If L1 dot data is smaller than, or even you can say equal to L2 dot data, that means if this is smaller than this, then what we should do, we should write L dot data as L1 dot data if this condition is true. Else L dot data is equal to L2 dot data. So if you have copied this here, then it makes sense to use 3 in the next step. Therefore, now this is no more useful. So we need to do 2 actions. One, shift L1. So L1 is L1's next, and then delete this node. So now once this is done, now this will be called L1. This is still L2. This gets deleted. So we get a 1 here. And then we repeat this, compare again L1 dot data with L2 dot data. L1 data is 3, L2 data is 2. Therefore, next time 2 will come here. Then 2 gets replaced. So L2 is shifted further. Then 3 and 5 are compared. And then you are sure 3 will come here. And then L1 gets shifted here. Then 5 and 8 are compared. So of course 5 has to win the race. Then that's also gets cancelled. Then L2 gets shifted here. Then 6 and 8, of course we get a 6 here. So this work is over. Then L2 gets shifted here. Then 8 and 20, of course it's 8. So this turn is over. Then this is L1. So L1 is pointing to 16, L2 pointing to 20. So definitely 16 comes first, and finally 20 comes. And that's the end of it. So what we have done is 2 pointers, one pointing to the head of the first list, another pointing to the head of second list, and compare the data of the 2 heads, and then whichever heads data is smaller, copy that to the main, and then move head to the next node, delete that used node, and that way you continue. So till the last node is copied, this is done. So at some time there won't be anything left in L1 or L2. So we have taken example of equal list. So it may not be true all the time. L2 may be a bigger one. So it may have another 5 more elements. In that case, once 16 is written here, then there is nothing left to compare. So L1 becomes null. So if L1 is null, then just connect whatever is L2 to our list. So that's going to be. So what does that say? If L1 becomes null, then else next is same as L2. So wherever L2 was showing, from there the whole thing you just append. Now if L2 becomes null, which means that L1 is a bigger one, therefore L dot next will same as L1. So that's the logic used, and this gets repeated till you reach the end of it. So when both are null, we stop the work. So that's the logic of merging 2 sorted linked lists. So hope concept was clear. And using these concepts, we can build further activities. So we look for many more such problems to be solved in the coming sessions. So keep watching. Thank you.